Hey, I'm Paul Van Metre on behalf of Modern Machine Shop Magazine. We are here at Addman Advanced Metals, formerly Keselowski Advanced Manufacturing, which was started only a mere 6 years ago by Brad Keselowski, the famed NASCAR driver. What we're about to go inside and see in this facility is something you have probably never seen before. This is a company that's taking metal additive parts from 10 by 10 cubed or smaller up to almost a meter in height, and then finish machining them in their machine shop.
That's not something you can just do on a CNC machine. So all these are 3D printed using laser powder bed fusion.
They went in the last 6 years from one machine to having 25 printing machines now, and a host of CNC machines from horizontals, verticals, integrexes, and 5-axis. So it is pretty darn cool. I can't wait to show you, and let's go check it out. All right, so we are standing in front of, what, about 10 machines? What do we have here?
Yeah, so there's
Tell us
10
about these.
EOS M280s in here. The EOS M280 is kind of a workhorse for us. It's considered a small frame machine. It's about 10 inches by 10 inches by 10 inches. We're using them in all kinds of materials. We use them in titaniums, Inconels, aluminums. Right now, almost every machine in here is in an M300 Metre steel for a specific project we have going on. But right now, it's a large-scale production run.
What's large-scale production for you guys?
4 years ago, we were making 2s and 5s and 10s of things. This customer came to us about a year ago and ordered 40 of this small part. And recently, they came back to us, and they were so happy with them, they ordered 19,000 of them. With the intention to double that in the next few months and continuing orders beyond that. So it's one of the biggest growth opportunities we've had internally is to take all of our systems and scale them up.
So if you do a 10 by 10 cube here, and you're doing small parts, you can do many at a time. Do you do multiple layers of the same part?
We do sometimes, but in most cases it's easier to just make one layer of a part. But in this case, it's a small part, maybe about the size of my hand. We actually stand it up, and we make rows of these parts. So there's about 50 parts on a plate.
50, okay. And then how long would a machine typically run, for example, with 50 of these parts?
These machines, these prints take about 3 days, just under 3 days.
So you've been here with Brad since the very beginning of the company. Tell us what inspired his vision to start this company.
Yes, so Brad basically has been in manufacturing his whole life. So he started off, with his dad and his uncle in their race shop. Then as he became a driver and, was ingrained in the motorsports industry, it really took off because he started to see AM parts infiltrate into motorsports. And then he saw them really producing performance results that were increased and heightened. And when he saw that, he really then saw the opportunity that capability could really enhance aerospace, defense, and commercial space launch.
So it's worth noting that we can't show many of the parts you make, but these are samples and some parts we can. So yeah, tell us what you guys specialize in.
That's an unfortunate reality of doing a lot of work in this commercial space. This part is actually kind of a generic injector, very similar to something used in the space field. This is just something that we threw together design-wise so that we can show it off. But it shows off some of the capabilities of really being able to create parts that have really complex internal channels.
Yeah.
Now, the machine shop
designed for additive,
exactly,
not just subtractive.
That's not something you can just do on a CNC machine. So all these are 3D printed using laser powder bed fusion. Laser powder bed fusion is a technology that starts with a thin layer of powder, uses a laser to solidify that powder, and then the whole part drops some small amount called the layer thickness. We spread another layer of powder on and lays that next layer. And one layer at a time, we create a solid part. That allows you to do all sorts of things like create parts with really complex internal channels that you can't even get to. Right. But we can exactly, but we can manufacture.
All right, this is kind of like the don't knock on the windows for the.
Yeah.
But yeah, tell us about these guys in here.
So our engineering layout, I think, captures exactly the way we run parts. And what I mean by that is we have 4 sections here, and each of them is a critical part of what we do. But it's laid out in such a way that they're constantly communicating. So our first layer is materials and processes. Then we have a section for our quality team. We have a section for our additive team and a section for our subtractive team. Okay. Before we ever print a part, if it's going to be machined in here, then our subtractive engineer and the additive engineer who are working on it will meet together, review added stock, review part holding, and all of that gets done before we ever hit print for the first time.
And then I also see they have a bunch of cameras all showing what, you know,
exactly.
From these
Every
machines.
one of these machines has a small camera on it, and that allows the engineers in there to watch all their builds. Yep. They can actually remote in right from home and watch their builds, because builds happen 24/7, and unfortunately so do build failures.
Oh, it's a car guy. I'm loving this part.
When your company was originally started by a NASCAR driver and a championship winning one at that, it's kind of hard not to have race cars here. One of the coolest things about them is when we first started as a company, we were looking for case studies to do. We were looking for things that we could make an additive and make better.
See that shifter.
And that shifter handle is the perfect example. And there's several other parts in here that you can see as well. So the shifter handle obviously is additively designed. The headrest support here is additive. The fire bottle mounts are additive. And you know, we didn't pretend that they were the perfect design at the time. What they were was proof of concept and proof of the ability to make parts that were lighter and stronger.
So are Brad's actual cars have any printed parts like those in them?
They do. Several under the hood.
Several under the hood. Awesome. So now we're going to go see your biggest machine.
Yeah.
Tell us about the travel and of this thing.
So the Velo Sapphire XC is an 8 laser machine capable of making parts, I hope I get this right, 600 millimeters in diameter and 550 millimeters tall.
Wow.
The build plate alone, before you start making parts on it, weighs several hundred pounds, and only gets heavier from there as you start adding metal to it.
So you have to climb a good 4 feet just to even look in the
just
window.
to get in. And the reason for that is this machine actually can be expanded to a 1 meter vertical height. So we actually had to lift this up to be prepared for that 1 meter expansion that wasn't available at the time we bought the machine. It is quite a monster. It allows us to make huge parts, and that's one of the things that the space industry is clamoring for. Right. Rocket engines they're pushing the reusability of those rocket engines, and in order to reuse those rocket engines and not make them be, you know, $100 million one-use things, the way to do that is through additive.
So when we were on the tour, Scott was talking about some parts that traditionally with a casting would take possibly 2+ years and possibly millions of dollars for making new molds. Right. And you guys would be able to produce that same kind of part in a matter of weeks. Can you just talk a little bit about that?
Yeah, and that's that flexibility. So, you know, whereas you have to have the very labor-intensive and expensive tooling created, et cetera, for, you know, a casting or something of that nature, we don't. So it is literally the speed that an engineer can create that digital file, and that's the lead time up to, that's our tooling per se. Our tooling is digital.
Yeah, so these don't look like printers. What are we looking at here?
They're definitely not. When you print a part in a bed of powder, you got to get that powder out.
Okay.
Now, if I was printing a simple solid block of material, that's very easy. The powder just kind of flows off it. But when you make parts with internal complex channels, you have to get the powder out of those channels. And that can be very, very tricky.
Yeah.
And it's really important to get that powder out before you send it off to stress relief or any kind of heat treat. Because if the powder's in there and you send it to any kind of heat treat, you're never getting it out. You now have solid material in there. Yep. So what this machine does, it's basically a platform that can spin 360 degrees like this, can rotate up and down, and has vibration inducers on it, high frequency and low frequency thumpers on it, to shake that powder, free it up, and get it out of all the ports that we print on there. So basically, get the powder out.
All right, we're in the machine shop, finally.
Yes, making chips.
I see a bunch of Metsuras, a bunch of Mazaks, both turning and milling and horizontal.
Yep, definitely machines for all different aspects. The Matsuras are great for their multi-pallet pool capabilities. You know, we can set up a lot of parts and jobs. They can be a variety of different jobs, and hit go before we leave for the night and let all those parts run and come back and have a bunch of good parts. So the operators, I think a lot of times people will walk through here and be surprised at how few of the spindles are spinning. But we really emphasize the fact that the guys should be spending their day setting up parts and the nighttime running them.
Yeah.
So it's really kind of a culture thing that we have to, you know, kind of share with the guys, is make sure those spindles are running when they're not here.
Yeah, these Integrexes are beautiful
Integrexes
machines.
are monsters, right? I mean, they're just perfect for large parts, really complex parts. They just give us a lot of capability.
Yeah, I imagine for rockets and aerospace, you're doing a lot of round things that have lots of features coming from all over.
Perfect for the Integrexes, yep. Yep, a lot of threaded ports, things like that.
And then a couple of horizontals here at the end.
Yep, horizontals we do for a lot of our plate production. We do some antenna components and some thermal transfer plates that run great on the horizontals.
We have, you know, differentiated ourselves by being able to basically do the precision CNC on 3D printed material. It's not always the same. And, you know, and everybody's like, well, machining's machining. No, there's a little bit of difference when you're handed a casting, and in this case, then handed an additive manufactured part that has even more geometry built in. So we always joked in the beginning, we actually could probably spend more time making a fixture than we actually did making part. So we realized there had to be some strategy brought to that.
The challenging part of additive parts is that we want to machine them with the same accuracy as the best high-end billet parts. But you're starting with a part that, number one, doesn't have two parallel surfaces anywhere on it.
Yep.
And two, has just a little bit of variability itself. And the key is fixturing the part.
Yep.
Well, how do you fixture an additive part? Let me show you. So when you have a complex additive part with lots of curves, the best thing to do is use that same additive machine to print a negative of the part. And now you have an additive fixture that is perfect for holding that part. Drill a few holes for a rock lock pattern.
Index pins.
And you're good to go.
You know, seeing the ability for additive to literally change parts and create parts that change the world, create parts that could never be made before, and just seeing those come to life, that's what is, I think, really fulfilling. And any new employee that comes to CAM, one of the first things I say is, you will always be challenged, you will never be bored, and it will never be easy. Because we are literally, you know, pioneering different realms of manufacturing right now.
Hey everybody, Brent Donaldson with Modern Machine Shop here, and if you just watched that video and you're thinking, boy, I'd like my shop to be featured in the View from My Shop series, then just send us an email at shopvideo@mmsonline.com and tell us what sets your shop apart.